Okay, so Mr. Yasin, today we are starting our lesson number 7, which is our dynamic routing protocol.
Yeah.
In this dynamic routing protocol, we will have three sessions. One is for RIP, second one will be for EIGRP, and third will be for OSPF. Okay.
Okay.
Okay. Now, okay. So these are the topics. So the first will be the routing introduction. Second will be our RIP configuration, then EIGRP, then OSPF. Okay.
Okay.
So same here. What is routing? So routing is the process which forwards the packet from one network to another network. Secondly, routing is used to create communication between two different unreachable networks, and routing is also helping us to find best path to reach from source to destination. Okay. This we already know that yes, our routing is divided into two sector. One is interior gateway protocol, means inside the organization, and second one is outside the organization. So these
Yes.
protocol which works inside the organization, and BGP is the protocol which works outside the organization. Means when two organization wants to communicate, then we need BGP protocol for making communication or creating communication between them. So static is already done, default is already done. Now in dynamic we are moving with RIP. Okay, so static routing, as you know that it's a manual routing for known destination, means you can only configure static routing when you know the destination. Default
Yeah.
routing is used for unknown destinations, and dynamic routing is automatic routing, that here we exchange the information with the
Okay.
neighbor routers. Okay. Now understand what is dynamic routing protocol. So dynamic routing protocol is known as adaptive routing protocol. Adaptive means they adapt the information of the neighbors, and according to the information received by neighbor they communicate. Like for example, just take that maybe you are one router and I am one router. So you will tell me that okay sir, I know these places in Norway. Okay.
Yeah.
Okay, then I will tell you, okay, then know these places in India. So I will exchange. So you will get my information and I will get your information, and according to that we will start communicating. Our routers will start reaching to the destinations. Now it is a technique. In this technique, router add a new route in the routing table for each destination network. So for reaching each and every networks, routers will have the information in the routing table. Okay.
Mm.
Now dynamic protocols are used to discover the new routes to reach the destination. Means if maybe if you have some information in the routing table, and that information has been deleted or removed automatically, so router in the dynamic session, in the dynamic routing protocol, automatically they will discover the new routes. If existing routes have some problem, so router will find a new route. Okay.
Okay.
Okay, so in dynamic routing protocol, okay, which are we have three protocols which works in the dynamic process. Okay, that is RIP, EIGRP, and OSPF. Okay,
Okay.
now here it is written that if any route goes down, okay, so this should be here. Okay, if any route goes down, so automatically dynamic routing protocol they make adjustment with the topology and they find a new route to reach that destination. Okay, now
Okay.
dynamic routing protocol have some following features. Okay, and what are those following features? See, all the routers must have same dynamic routing protocols running in order to exchange the information. So if your maybe if you have one router and I have one router and the both routers are connected, and in dynamic routing, if you want to exchange the information, so dynamic routing protocol must be same by default.
Yeah.
So if you are using RIP and so I'm also using RIP, then we could exchange the information. Otherwise, we have to use some kind of redistribution if you are using different protocol. But we are right now we are talking about default communication. Okay.
Okay.
Now, now if the router discover any changes in the condition or topology, then router broadcast or multicast message for this information to all the routers. Means if you have some changes, maybe if you have, maybe there is one router, and if this router have some port connected or interface connected, and maybe this interface have some changes like port has gone down, so immediately this router which is connected with another router, it will inform that please there is some changes. Okay.
Okay.
But this kind of information will never be exchanged or informed to neighbor in static routing and in default routing. Some other information in dynamic routing, like in dynamic routing, routing table is created, maintained and updated by routing protocols running on the router. So here administrator doesn't have to do anything. Once you have enabled the routing, dynamic routing, automatically router will be working according to the condition and topology. So this we already know. Yes, we have some dynamic routing protocols, REP, EIGRP and OSPF. Router do share dynamic routing information with each other in the with other routers. Okay, that's why as CPU, RAM and bandwidth are always utilized in dynamic routing. So, as compared to static and default, dynamic routing protocols use more resources for communication. Okay.
Okay.
Okay, dynamic routing protocols are capable of choosing different or better path, okay, dynamically or automatically, okay, to communicate from source to destination.
Okay.
Okay, and dynamic routing protocol, they share the information to neighbors, the connected network information, and according to that they build the routing table, and based on that routing table they define best path, and according to best path they communicate. Okay, so some advantage and disadvantage of dynamic routing protocols. The advantage of dynamic routing protocol is it is easier to configure, it is faster to find the best and alternate path to reach destination, it is more effective in selecting the best route in response to the change in the condition or topology. But if you will compare with the static and default, so you have, if there is some changes, you have to change manually, but here it is automatic, that's why it is best. Disadvantage is what it is little bit expensive in term of CPU and bandwidth use. Okay, because see every time when you will send some kind of message in the network, so you will be utilizing the bandwidth of the network. Okay, and it this one is by default, this one is less secure as compared to a static. But I'm saying by default. Why? Because if you want to secure the network of dynamic, so you have multiple options like access list. You can create some kind of password authentication between two routers. Okay, so that is external. But default, when you are talking default, okay, so in default process, dynamic is less secure than a static. But to secure dynamic routing protocols, we have some other features. Okay,
Okay.
that will come to know in our security. So as we know that yes, dynamic routing has three categories. One is distance vector routing protocol. Second one is hybrid routing protocol. Third one is link state routing protocol.
Listed. Right.
Yes. So distance vector routing protocol is RIP. Hybrid is the combination of link state and distance vector. Okay. So how
Okay.
why they are calling it as a distance vector? Because it calculates the distance or as a hop. Okay. Link
Okay.
state means OSPF is a link state means it works on the behalf of link state. Link means the cable which is port which is connected. Okay, there is two router and this is the link and they work on the link state. And EIGRP is the combination of both. That's why it is known as hybrid. Okay, we'll
Okay.
come to know slowly how it works. Okay, now we are working with RIP routing information protocol.
Okay.
Okay. Now, so RIP stands for Routing Information Protocol. Now, RIP is a standardized distance vector protocol designed for used on a small network. Okay. Now,
Okay.
RIP, if you want to use RIP for a large network, then it's not a recommended protocol because RIP can use for a small organization only because it supports only 15 hops or 15 gateway.
Gateway.
Yes, means like if you are here and you want to reach here, okay, so one
Okay.
hop, two hop, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, something like that. And if you, so this is hop, one hop, two hop, 3, 4, 5, 6, 7, 8, 9. But if it is the destination is more than 15 hop away, then the destination will be unreachable. Okay,
Okay.
so, but if you'll see the large organization, you will find 100 routers, 50 routers in the organization. Okay, so in that case they do not recommend RIP. RIP use UDP protocol port number 520 as a transport protocol for sending the updates to its neighbor. Like see, RIP is a protocol, right? But when RIP wants to send some information to its neighbor, okay, so RIP use which protocol? UDP protocol for sending the information to the neighbor. Okay. Now,
Okay.
by default, RIP support for equal path load balancing. We will come to know, okay, for equal path load balancing how it is working. Okay. Now understand this one. RIP sends full routing table update to its neighbor in every 30 seconds, and this information is periodically sent to the neighbor in every 30 seconds. Like in every 30 seconds I'll be telling you that okay, my name is this, I'm from here, this is my information. Okay, so the same information will be sent to the neighbor in every 30 seconds. Okay, that's why little bit RIP is little bit slower. Okay,
Okay.
now RIP routes whatever information you are receiving from RIP. Okay, so the administrative distance will be 120. Okay, and whatever information you are receiving through a static, the administrative distance will be 1, right?
Right.
Yes. Now RIP routing protocol shares its locally connected networks to its neighbor. Okay, and once they exchange this information, after that they create the routing table, and after that routing table they find the best path to reach to destination. Okay, here RIP has two versions. Okay, version 1 and version 2.
Two.
Okay, now RIP version 1 is known as class full routing protocol, and RIP version 2 is known as classless routing protocol. Okay.
Okay.
Now, what do you understand about classful routing protocol?
Classful routing protocol.
Yes.
Um, I think is only one use the address for one class ID.
Okay. And RIP version 2?
Version 2.
Yes. See, what do, sorry, I'm talking about what is classful routing, what is classful route, what is classful IP?
Full. Yeah.
What is classful? Tell me.
The classful ID
Yes.
is like a broadcast address.
No, 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 no. Let me explain you. See. Okay. Right now, I'm writing this IP address 10.10.10.10. So this IP belongs to which class?
Class A.
Class A. Very good. Okay. Class A. Right.
Right.
Okay. So what is the default subnet mask of class A? Default
Uh,
subnet default subnet mask of
is
class A.
233 or 255
Okay.
000.
Okay. Why it is like this? Because class A use 8 bit, right?
Yeah, right.
Okay. So this is known as prefix. Whenever you see something like this 10.10.10.0 slash 8, okay, so this is known as what? Prefix. What is known as? This is known as prefix.
Prefix.
Prefix. Okay. And so this is known as subnet mask. Okay.
Subnet.
Yes. So whenever any if you see slash something, so this is prefix, and when you see 255, so this is subnet
Prefix.
mask. Okay.
Mask.
Slash is known as prefix. Okay.
Okay.
Okay. Now, but if I'm writing like this, some IP, if I'm using some IP address 10.10.0.0 slash 16. Now tell me, this IP belongs to class A or some other class?
Yeah.
No, so this IP belongs to which class?
This, this is class A. Class B because all is a class A because
Okay,
the first
okay, so this is class A. Okay, what is the subnet mask according to the
is
prefix?
subnet mask
Yes,
is 233 two uh, no.
no, here I have given you 16 bit, right?
Yeah.
So according to bits, you have to assign I subnet mask, right?
Right.
Yes. So here, this IP belongs to class A, I am understanding, but the subnet
Yeah.
mask is different, right?
It's different.
Yes, that's why. So these kinds of IP address is known as classless. Means you cannot define the class of this IP because by default, see this IP belongs to class A, but the subnet mask is different. Are you understanding?
Okay.
So that's why it is
Yes,
known as
sir.
classless IP is subnet. Okay, this
Okay.
is classful.
Classful.
Yes. Okay.
Okay. Okay.
Now, if I'm writing this one 172.16.10.0 slash 24. Now tell me this IP belongs to which class? Is it a class full or classless? So this prefix which I
This
have written here, is it a classful or classless?
is class
Class
classless.
classless.
Classless
Why?
because the address is for the class B,
Yes,
but the subnet mask is for the class C.
yes, very good. So here, so RIP version 1 only support classful IP address.
Okay,
Okay, and RIP version 2 support classless IP address, means those subnetting. Okay,
and
so
different.
subnetted IP addresses will be supported by RIP2, but the default IP address, which is class A, class B, class C, will be supported by RIP1. Okay,
Okay,
now RIP version 1, whenever RIP version 1 wants to send any kind of information to its neighbor, it use broadcast address 225.225.225 for sending the information. But when RIP2 is
okay,
sending this information, it will use 224.009. Now what is the difference? RIP1 will send the information, so it will send to everyone in the network,
in
whether
the
they are
network.
RIP, they are EIGRP, they are OSPF. Okay, everyone will receive this RIP1. Okay, but
Okay,
RIP2 will only send to those routers who is running RIP. Okay, because this is
okay,
RIP multicast address. Okay,
okay,
now RIP version 1 cannot work with subnetted networks, and RIP2 will work with subnetted networks. Okay,
okay.
so this you will know on when you will learn some kind of CCNP kind of thing, like what is contiguous network and discontiguous network. Okay,
Yeah,
RIP version 1 do not support authentication, and RIP 2 supports authentication. Okay,
okay,
so we will be covering this authentication in this session, but authentication is the part of security. Okay, but we will be covering here as well. Okay,
okay,
okay. So now when we are talking about RIP 1 configuration, then we will see how to configure RIP 1, and then we will see how to configure RIP 2. Okay, and what is the why RIP 1, like what was the problem in RIP 1. Okay, so we'll see this in our lab. Okay, now tell me one thing here. This, can you see this this 12.0.0.0.8, right?
right.
Okay, so this is classful or classless?
Classless.
This one 12 belongs to which
Class 2.
classful. Okay, but if I'm
Yeah,
using this one, okay, if I'm using this one is classful or classless?
classless.
This one is classless, right?
Right.
Okay, this one, this
Um,
one,
this one
yes,
is uh, classless,
classless, and this one,
and this one classless.
okay, and this one,
Classful.
classful. Okay, good. Okay, so now we are working with the labs. Okay,
Okay.
so let's start with the RIP 1 lab. RIP, RIP version 1 lab. Okay, so here we are using 192.168.10.0/24 subnet. Okay, and here we are using 20.0/24 subnet. So we can change this IP address 20.1. Here is 20.2. Okay, and here is 20.10. Speed we will talk later. 12, 13, 23. Okay. So this is one LAN. Okay, this is LAN, right?
Yeah,
Okay, and
right.
this is one is another LAN. Okay, so always keep in mind whenever we talk about any kind of lab. Okay, so first of all we design the network, right?
Right.
Second, we connect the labs, or you can say connect the devices with the correct cable. Okay.
Okay.
Okay, now after that we define network of your devices, means we define the
Yes.
network, or you can say subnet. Okay, subnet or
Okay.
network or subnet. Okay, for the devices. Okay. Now number 4, configure the IP addresses, right? Okay,
Right.
so let's come to the number 4. So we'll start all the devices. Okay, and then we'll take a console. So PC1, PC2 is after that we have router 1, router 2, and then router 3, then PC3 and PC4. So what is the IP address of PC1? So we'll see here. It belongs to, see here, class. So here we are using class full, right?
Right.
Okay, so we'll change the IP segment. So we'll write here IP 192.168.10.1, but it is class full, but gateway is this one. Is it okay?
Okay.
Okay, let's come to PC2. PC2 IP address is 10.2, and then gateway, subnet mask, and slave. Router 1. Enable conf t, then will come here interface serial 2 by 0. IP address is 12.1.1.1.255.0.0.0.0, right?
Right.
Okay, enter, no shut. Then you can write exit and then interface E0/1 IP address is 13.1.1.1, no shut. Two interface completed. Now we are moving to another interface. Interface is 0 by 0. IP address 192.168.10.10, and the subnet mask is from class C, and then no shut. Is it okay? Any question?
Any question? By now, any question?
Okay. Now you can type here so IP interface brief exclude unassigned. So you can see here all the three IP addresses of the interface is configured properly, right?
Right.
Okay, now we are moving to router 2.
Sorry, sir.
Yeah.
What is the difference between the different method we have there? Method we have there,
Here,
manually and NV RAM.
serial 2 by 0.
Yeah,
I don't know why it is coming like this. Let me show. So running config Ethernet for Ethernet. Okay, serial 2 by 0. Serial 2 by 0. Serial 2 by 0. No, it's a problem of the software because here when you see NVRAM, right?
yeah,
Okay, means this information is already stored in the
NV RAM.
NVRAM. Okay, so if you will come
Yeah,
here, write it, save it, okay, and then check. Okay, then also it is coming same like that. Okay,
okay.
okay. See why it is coming like this. Let me explain you. This lab was already pre-configured. Okay,
Yeah,
okay. So this IP was same here, and it was already stored in the RAM, NVRAM. Here it was stored as a 131110/30 in the NVRAM, but now I changed to like this one. Okay, so for
okay.
13 and 19, this one E0 means E0 by 1 and E0 by 0. It is showing as a
Yeah,
manually configuration, and this one is showing that it was already saved in the NVRAM. Okay,
okay.
but when I will restart this router, let me restart this one. I have saved it. Okay, and now what I am doing, I am coming here, uh, stop and start. Enable show IP interface brief, exclude on assignment. See, can you see here?
Okay.
Now all the information is saved in
In NV RAM.
NVRAM. Okay, why earlier it was showing for this two, it was showing manually? Why? Because I have changed the subnet. That's why. And here for this network, I configured newly, but I did not change the subnet, and it was pre already saved in the NVRAM. That's why. Okay. So here I
Okay.
overwrited. Here I overwrited means I changed. That's why it was showing you as a like manually, and here it was default. That's why it was showing you.
Right.
Yeah, it was means like I did not change. It was predefined. Okay. Here also you will come to know like see enable
Okay.
see show IP interface brief exclude unassigned. So you can see here we have few IP addresses saved here. Can you see here?
Yes,
NVRAM.
yes.
Okay,
Okay.
and it is saved as per 8 subnet default. Okay, so R2 is already pre-configured. Okay, now let's come to R3. R3, if you'll come here, so IP interface brief exclude unassigned. So you can see here, here is also pre-configured, right? R3 has also
Right.
3 interface and it is pre-configured, but our problem is uh, if you check here, so running config. Okay, now see here E0 by 0, E0 by 0, it is this is classless or classful?
That one is classless.
Classless. But here in the scenario in the lab, I have given you classful IP, right? Slash 20 slash 24, right?
Right.
Are you getting? So here, what I am going to do, I am going to change here E0 by 1. Is it a classless or classful?
This one
This one,
is class is
classless.
classless.
Yes. But according to the scenario, I have given you classful, right?
Right.
Yes. So we are going to change here. Okay. Here, this is what? Classless or classful?
Classful.
Classful. Okay, very good. So let me come here. Interface E0/1 IP address 13.1.1.2 and no shirt, and then interface E0/0 IP address 192.168.20.10, and the subnet mask is this no shirt, and then interface serial 3/0 IP address 23.1.1.2 no shut, and then save it and then check with this command. Now see, for this one what I did, can you explain it? See
For
here,
this one.
yes, for Ethernet E0/0 it was class less IP address, but I made it class full. So what I did, I changed from older to new, right?
Right.
So that's why it is coming as a manual.
Manual.
Yes. Okay. Here also I made it from classless to class full. That's why it is coming as a manual.
Exactly.
Okay. And here it was already class full and I changed to class full. So it is same.
Okay.
So there is no changes. That's why it is NVRAM.
Yeah.
Okay. But when our
Okay.
yes. Okay. So PC3. Now we are moving to PC3 IP 20.1 and the gateway is 20.192.168.20.10. Save it. IP 192.168.20.2.255 and the gateway is 20.10. Okay, PC1, PC2, all is done. Now if PC1 wants to communicate to 192.168.20.1, see, no reachability, right?
Right.
Okay. So now we are coming here to R1 to check his routing table. So IP route. Here R1 is saying that my friend, you want to reach 20 network and 20 network is not in my routing table. That's why I am not providing you reachability. Okay.
Yeah.
So in dynamic routing concepts, we have to advertise our own connected network. C means connected network. Okay. So
Okay.
how many C you have? How many connected networks you have? Three network of on R1. How many networks you have? This 12, 13 and 192.168.10.0, right?
Right.
So you have to come here, you have to type here router rip network. So according to what you are getting here, you have to type like that. Okay.
Okay.
So you type it. If you want to type 12.1.1. No problem. If you want to type 12.0.0.0, no problem, because it is class full. So what
Full.
if you are typing here 111, so RIP will not understand. So if you are typing 1, no problem, but RIP will understand that as a 12.0.0. Okay.
Okay. Okay.
Network. Now you have another network 13.1.1.0. Then you have another network 192.168.10.0 and then exit. RIP is done. Now if you're coming to R2, you have two networks, you can see here, right? So IP route. So here what is the meaning in dynamic? You have to only say that yes, I have two networks. Simply you come here,
Yeah.
you say that okay, I want to enable RIP protocol and I want to advertise two network. Which one? 12.1.1.0 network 23.1.1.10 and then exit. Same here also R3. See here, if you type here, so IP protocol. Do you have any protocol running here? No protocol running, right? So come here. So IP route, then type here conft router rip network 13.1.1.0 network 192.168.20.0 network 23.11.10 exit. Okay, and now if you're coming to R1 here, type here. So IP protocol. See, which protocol is running? RIP is running, right?
Right.
Okay, what is the version of that RIP?
One.
1. Okay, and now if you'll type here, so IP route. See, are you getting some information through RIP? Okay, so you are receiving 23. See, here
Yeah.
R1 is only directly connected with 12 and 13 and 192.168.10.0, right?
Mm.
R1 is not connected with 23 and 192.168.20 network, right?
Right.
So R1 should receive how many network from its neighbor?
Two network.
Two networks. Very good. So let's come here and see how many networks R1 is receiving.
Sorry?
R1 is receiving how many networks from its neighbor? See, can you see here? 12 is directly connected. See here, directly
Directly.
connected. 13
Yeah.
is also
Two.
directly connected. But this one
Yeah.
is receiving from its neighbor IP address. Can you see here?
I can. Yeah.
And this. But you will say, sir, here I'm getting the combination of my network plus my neighbor in network. So can I filter it? Yes. You type here. So IP route. So here you are getting only your neighbor information.
Information.
Okay. Neighbor
Okay.
network information. Okay. Can you explain me this one?
Yes. The first route.
No, no, no. This one, this one. The one which I have selected here. 120. What is 120?
120
Yes.
is the distance.
Administrative
The
distance.
vector distance.
Okay. Okay. So 120 is administrative distance, right?
Right.
Okay. And what is this one?
The one is only the one neighbor.
No, one hop.
One hop, sorry.
Yes. See, if this router wants to reach here 23, right? So
Yeah.
23, if I'm jumping from R1 to R2, so R2 is saying yes, 23 is my connected.
Yeah.
Okay. Now see, R1 is jumping from here to this router, R3 is saying yes, 20 network is my connected network. Okay.
Yeah.
Now,
Yeah.
now you'll say, okay, sir, can you make it 2? Yes, no problem. What you do, you come here to R1, and what I will do, let's disable this link, okay, E0 by 1, okay. So I'll come here,
Okay.
conf t interface E0 by 1, little bit shut, no problem. Okay,
Okay.
okay. So now, so you can see here interface is down, and once you are checking here, so IP route rip. Okay, just a moment, it is updating. It takes 30 seconds. Okay, just wait. So once we shut down the interface, which interface? E0 by 1. Okay, now let's see. You are receiving 192.168.20.0. Can you see here?
Yeah.
Two hop away, right?
Yeah. Two
Okay,
hop.
and earlier it was one hop away,
One.
and the
One.
neighbor was 13.1. 1 2 directly connected, but here now neighbor
Connected.
has changed 12. So 12 is saying that okay, if you want to reach 20 network and this link is down, so it is 1 hop 2 hop. Okay.
Yeah.
Okay, now what we can do, we can come here and again I will enable that one. Interface E0/1. No shut. Okay. Okay. So you can see here the interface is up now. So IP route and now everything came back. Okay.
Okay.
So this is your RIP version 1 configuration. Now tell me, did you saw any problem in the configuration?
No, no.
No. So
But I
you
have one question.
yes.
Yes, I want to know the difference between these two kind of commands, IP root and root rip. There is a difference?
Yes, yes. See, if you will type here, so IP route, it will give you your connected network plus received network.
Okay.
And if you will type this one, so IP route RIP, so only RIP means received network through
Received
RIP.
network. Okay.
Okay.
And in when we make the configuration,
Come again?
in configuration, when I make the configuration, I can use as IP route or root IP. It's not a big problem.
No, no, no. This is to get the information output.
Okay, 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 okay,
Okay.
okay.
Okay. Now, okay. So my question was, did you saw any problem in RIP version 1?
No, no, no,
No.
no, no.
Then why they have they came with RIP version 2 if there was no any problem in RIP 1? So we should
Excuse
know the
me?
problems, right?
Right.
Okay, now see the problem first. Debug IP RIP. Receive update from this neighbor on this interface. Okay,
Okay.
okay, and sending update via this broadcast address, right? It's not a
Right.
multicast. On all is to stop. This was just a information, the receive information and sending information. Okay.
Okay.
So he's saying that when I'm receiving, I'm receiving the information from my neighbor. It's okay. But when I'm sending through 225, 225, 225. Are you getting?
Yeah.
So RIP version 1 message can be received by any kind of network router, any kind of everyone will receive.
Yeah.
Okay, so hacker can also receive this information. Non-hacker can also receive this information. So unnecessary, this RIP version 1 is sending broadcast message to the network. Okay,
Okay.
first thing. So first problem. Second problem is, now let's come here. So we are going to change the subnet. Okay.
Okay.
So here what I will do, I will write here /29. Okay, or /26. You can say /26. Okay, and here I am using the second subnet of 10.0.64/26. Is it okay? It is correct or wrong?
The second is wrong.
This one,
Is wrong.
my friend, have you done subnetting?
The subnet is correct, but is not the address of the network because you put 64.
Yes, 64 is not address.
Yeah. Okay.
You forget.
Okay. Okay.
Check the subnetting again. Okay, 192.168.10.65, 66, 70. Let's give 70.
Okay.
Here is 192.168.10.65, 192.168. One 168.10.66. Okay, so we are going to change some subnets. Let's just start this one. Okay, before that, I'd like to show you something. So IP interface brief exclude unassigned, right? So
Right.
here, whatever we have given here, all is classful IP, right?
Right.
Okay. Debug IP array. So when this R1 is sending the information to other neighbors, so it is sending as a classful, right?
Classful.
Yeah, sending as a classful, right?
Right.
Okay. Okay. So now we are changing the subnets. So we are going to change the subnets of here only this one, just this LAN information. Okay, forget about others. So I'll come here interface E0 by 0 IP address 192.168.10.10 is okay, only we are changing the subnets. So 190, no shit. So here also PC will be changed. So I'll come here IP 192.168.10.2 slash 26 and the gateway is 192.168.10.10. Okay, 10.1. Okay, then save. What happened? 192. I'm on PC 1. Save. PC 2 IP 10.2 gateway is this one. Save. PC 3 IP 192.168.10.65/26 and the gateway is 10.7. Save. This is subnetted IP, okay?
Okay.
66. Save. Okay. R1 IP address is configured. Now we are moving to R3. Enable conf interface E0 by 0. IP address is 192.168.10.60 sorry 70 and the subnet mask is 255.255.255.192 and no shut. RIP protocol is already enabled. If you come here R1, so IP protocol, see RIP protocol is already run. Okay, and if we'll check here, so IP route is already there, and you can see here communication is there, no problem, right? RIP is running. Okay, now see,
Okay.
So R1 have 192.168.10.0, right?
Right.
But R1 doesn't have, if you'll check here, PC1 try to communicate to 192.168.10.65. See, destination host unreachable. Even RIP is working. See here. Okay. Now see what is the problem. Problem is when R1 is trying to advertise this network, right,
Right.
to R2. Okay.
Yeah. Okay.
So automatically this network is changed. It will change from classless to classful.
To
Okay.
classful.
Yes. Again, this one will also, this R3 will also advertise this one. Okay. Sorry. When R3 will advertise this network to R2, automatically it will be converted to classful, not classless, because RIP version 1 support classful, not classless. So if you'll advertise classless also, so it will check only the first octet and it will say, okay, you belong to class C. Okay, no problem. Let me convert it to class C subnet. Okay.
Okay.
Then it will come here as a like this. Okay. So let's come here. R2. Let's see what R2 is receiving. Enable show IP route. Now R2 is saying, okay, did I configure this R3 E0 by 0 192.168.10.70 so IP route clear IP route star so IP route. Okay, fine. It was some older information was there. Clear IP route. This command is to refresh the routing table. Okay, route star and then so IP route 192.168. Okay, no problem. What we can do here, conf t router rip. Let me remove the configuration first. Okay, no router rip. Come here, conf t no router rip. R3 also conf t no router rip to remove the rip configuration. Okay, now if we come to
Okay.
R1, so IP route, no routing. Okay, no problem. Come here, type here router rip network 12.1.1.0 network 13.1.1.0 network 192.168.10.0 exit. Let's come to R2. Serial. Okay, route router rip network 23.1.1.0 network 12.1.1.0 and then exit. Fine. Now let's come to R3. Router rip network 231110, network 131110, network 192.168.10.64 exit. Okay. Now,
Okay.
now let's come to R. Okay. Now you type here, so IP route. Now see, R2 is saying I am receiving 10.192.168.10.0/24.
24.
Yes. Are you advertising /24? Are you advertising? R1 is advertising /26. But R2 is receiving what?
24.
R24. You are at R1 is advertising /26, but R1 is receiving R2 is receiving /24. Again,
24.
R3 is advertising /26, but R2 is receiving
6.
/24. So R2
Yeah.
is saying I am receiving 10.0 from R1 and 10.0 from R2. Are you
Yeah.
understanding? So
Yes, I
for
understand.
this is the load balancing. Means if any people which is connected to R2, maybe someone is here, okay, from someone is here, if they will send some packet to 10.0 network, so one packet will come here and one packet will come here. So one packet will communicate and one packet will drop, right?
Okay.
Yes. So this is a wrong configuration. Are you understanding?
Okay.
Now, so now see, now understand this one. Now R2 will say, normally R2 has to exchange this information here, okay,
Yeah.
and this information here, right?
Right.
Okay. So let me delete this link for just, or maybe shut down this link for to understand few things. Or let's delete this one. We will connect later. Easy. Okay. So R1 R2 is saying, see, normally R2 has to exchange here and R2 should exchange here. But R2 is saying
Yeah.
that I cannot exchange because R1 is sending me same information and R2 is also sending me same information. That's why I could not exchange it. Are you understanding?
Yes, I
That's
understand.
why R2 is not sending any information to R2. So, sorry, R3. So IP route. Okay. See here. No any kind of information regarding 192.168.10.0. That's why there will be no communication. And
Mm.
if you will come here and run this command, debug IP debug IP rip, see, sending on all. See here, it do you see any kind of subnet information /24/26?
No,
No.
no.
And see here, R3 is also sending debug IP rip. R3 is also sending class full information to R2. Sending, see, can you see here? Sending this one on all to stop. Sending this information. So can you see any kind of information here like 10.0/64 something like that?
No, no.
No information. Okay. 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 That's why. when R3 is sending these kind of information, that's why R2 was receiving like it. Okay,
Okay.
but there will be no any kind of communication when when PC1 of this network, PC1 PC1 of R1 network, okay, wanted to
Okay.
communicate, okay, wanted to communicate to this R2 R3 sorry, R3 PC3 PC4 network. Okay, they are not able to communicate, right?
Right.
So what we can do, okay, so see what is the process is you just come here to R1 and you have to enable R, like RIP version 2. Very simple. See what you do, you come here, you router RIP version 2 network. You say that okay, I have 12.1.1.0 network connected, no problem. Network. So this time I'm not adding 13 because I have deleted the link. Okay,
Okay.
192.168.10.0, and here you have to type here no auto summary exit. Okay, no auto summary means, see here what was happening when you R1 was sending some information, so it was summarizing it, right? Summarizing means it was changing to default, right?
Right.
But with this command no auto summary, R1, you are telling R1 that please do not summarize my network, keep as it is. Okay,
Okay. Okay.
now come to R3 also. Conf router RIP version 2 network 23.11.10 network 192.168.10.64 no auto summary, and then exit, and let's come to R2 as well. Conf router RIP, okay, version 2, okay, network 12.1.1.0, and then network 23.1.1.10 no auto summary, and then exit. Okay,
Okay.
now what is happening if you check here, so IP protocol, you can see here which version is running now, version 2 is running, right?
Movement to.
Yes. Okay, so what you type here, clear IP route, just to delete the older RIP1 information. Okay, clear IP
Okay.
route. Okay, and here also type here clear IP route, and now if you will come here to R2 and type here, so see here, now R2 is getting what, subnetted information or what? See here, both information, right? See,
Both information.
yes. And now if it is like this, so see communication is there, they are communicating, and if you will debug,
Yeah.
now see debug, you will see RIP2 information. Debug command is to check the background process, okay,
Okay.
background messages which we cannot see normally.
Mm.
See, on all. See, now can you see here, now they are sending the information with subnet mask or without subnet mask?
With subnet
With
mask.
subnet mask. Now, so in RIP version 1, whenever they send some information, see, if I will send you some information, if I will send you some information in RIP 1, okay, but I will send you like this, so what you will understand, you will understand this as a class C or some other.
Classy.
Yes, why? Because I'm not sending any kind of subnet mask to you, right?
Mask.
But in
Right.
class in RIP 2 they send like with subnet mask. That's why RIP 2 will say okay, this is class full, okay, no problem, sorry, classless, so let me add it as per your given information. Okay,
Okay.
that's why it is like this, and according to that R2 has stored the information. See, R3
Yeah.
is also sending like this. See, debug IP rip. It is sending like this. See, can you see here?
Yeah, I see.
Sending 6426 like this.
Mm.
Okay, via 224009 multicast address of RIP.
Mm.
Okay, so today what we have seen, what is RIP 1 and RIP 2, the difference between RIP 1 and 2, right?
Right.
Okay, and few show commands, right? We have seen some show commands, right? Okay,
Right.
and in the upcoming class, like I have explained you what is auto summary. Auto summary is command to explain or to
To help.
disable, yeah,
Yeah.
default summary, okay, default summarization. But by default,
Okay.
rip 1, when you will use no auto summary, automatically rip routing will understand that okay, you want to enable rip version 2. Okay,
Okay.
if you will not write no auto summary, means it is rip 1. Okay, but when you will
Mm.
write no auto summary, means it is rip 2.
Okay.
Okay, then in the next class we will come to know some other advanced topic of rip. Okay,
Okay.
or what we can do, let's complete it because we have only few things in RIP. After that we have EIGRP. Okay,
Okay.
okay, now we have RIP timer. Okay, so let's understand about RIP timer. So if you will come here on okay, so if I'm coming to RIP 1 and if I'm typing here so IP protocol, so you can see here there are some timers. Okay, okay,
Okay.
so understand about this timer. Timer is, if you want to send some information. Okay, so this is informational timer, means
Yeah.
how much time you take for sending information, how much time you will wait for another information. Okay, so first is update timer, and this is very much important to understand. Okay,
Okay.
now see, update timer, time between each update. Okay, means
Okay.
the rip routers sends the information of the networks or subnets to in its neighbor in every 30 seconds. That is known as update time. Okay, and this is periodic.
Okay.
Okay, now what is invalid? Invalid means, suppose you router 1 has given one network like 20 network information to R2, right?
Right.
2000 something like that. But due to some problem with the cable or something, R1 is not able to send the information, the second information or second update in that 30 seconds, right?
Right.
So R2 will wait how long to say that the information which I have received for 20 network, that is invalid. Are you understanding?
Yes, I understand.
So R2 will wait for 180 seconds to make that network, the received network, invalid. Okay,
Okay.
just okay, so invalid is what, that the information what R2 has received from R1, and when R1 is not sending periodically update about that 20 network.
Okay.
Okay, okay, so now did you understand invalid?
Yes, I understand.
Okay, now when R2 made that network invalid, right,
Right.
then R2 will say that R some other network is also connected via R2, right?
Right.
Okay, no, sorry, I explained wrongly about invalid. The one which I told you about, that was for hold down timer. Okay, hold
Okay.
down means if the information which is received by R1, okay, and R1 is not sending any information, second information about that network, but okay, so R2 will wait for 180 seconds to receive that information. If R1 is not sending, so it will declare that network is unreachable. Okay, now
Okay.
when it will reach 180 seconds, then it will make that network as a invalid, and it will inform to the neighbors that please, the information which I have sent to you, means see, here is R1, here is R2, here is R2. R1, R2, R2. R1 has sent about some network to R2. R2 is waiting for that network information, okay, for 180 seconds. If R1 is not sending, so R2 will make that network as a invalid. But for making that network invalid, R2 will wait for hold down timer 180 seconds. Okay, so this
Okay.
both timer is running together, and then R2 will inform R3 also that please, the information which I have sent you, this 20 network, please make that network invalid because R1 is not sending me any information about that one. Okay, so
Okay.
once the network is invalid, so the network should be removed from the routing table. Okay,
Yes.
so after 240 seconds, that network will be removed from routing table.
Okay.
Okay, but according to this, so this timing is very long timing. Okay,
Yeah.
okay, but if you want to make RIP little bit efficient, so you can change the timers. See, the
Okay.
5 you can make the whole update timing which is 30 to 5. Okay, hold 180 to 10, up invalid to 20, and flush to 30 instead of the default one which is here 30, 180, 180 to 40. Okay, and this is for changing the timer, and again if you want to make it default, so you can change this one as a default. Okay, so let's see this one. Okay, do so IP protocol. Okay, so you can see the timers. Now if you want to change the timer, so you just type here router rip. Okay, timer basics 5, 10, 20, 30, and now check. So IP protocol, you can see here timing is changed. Okay,
Okay.
okay, and if you want, and always keep in mind the neighbor timing. See here R2 timing is default, so IP protocol R2 timing is still default. Can you see here?
Yeah.
Okay, so it doesn't mean that the neighborship will go down. No, in RIP it is not like that. Okay, and if
Okay.
you want to bring that timer default, so you can come here simply router RIP, and you can see here no timers basic. And now if we'll check, so IP protocol, it is default. Okay,
Okay.
okay, now here we have some other topics, which is passive interface and authentication. Okay,
Okay.
okay, so as we have completed the RIP timers, okay, now we are moving to RIP passive interface. Now what is RIP passive interface? So first let me show you something, then you will come to know about RIP passive interface. So if I am here on R1 router, and here I am running one command, debug IP received. Okay, fine, sending update, sending update, sending update. you can say on all. Now see, earlier we were having one interface here, so let's connect that interface if you want. E0 by 1, I think it was that one, E0 by 1. Okay, and you'll see here that R1 is sending RIP version 1 update via E0 by 1 is okay, no problem, because here R1 is connected with R3 via E0 by 1. That's why R1 is sending via update this one. Okay, no problem. R1 was also sending RIP update via serial 2 by 0 to its neighbor. So it's okay. Serial 2 by 0 to its neighbor. It's okay. But R1 is also sending RIP information to EI to interface E0 by 0 towards its LAN. Okay. But now tell me, do you have any router here to understand RIP messages? Here you have PC, here you have switches. So who will understand RIP messages? So unnecessarily you are sending, means R1 is sending RIP message towards its network. You can see here, see, towards its E0 by 0 this network. So unnecessarily you are sending, means R1 is sending these type of information towards its LAN. So whenever any LAN network is connected towards your, like this, any interface is connected towards your LAN area, so in that case you can stop sending RIP updates via the passive command. So that is passive interface, so you have to make that interface as a passive. So router RIP, as we are using version 2, then you can write here passive interface E0 by 0, and now if we'll type here so IP protocol to see which interface is passive. Now you can see here, and now you are running here debug IP. Now you see, so it will be sending update message via only serial 2 by 0 and Ethernet 0 by 1, not via Ethernet 0 by 0. You'll see. Okay, so now what you have understood here, so you have understood here that passive interface is interface where RIP router do not send any information, any RIP information, okay, RIP update information. Okay, see, sending via E0 by 1 but not sending via E0 by 0. Okay, so always keep in mind, in RIP passive interface, that interface, which interface is passive now, this E0 by 0 is passive. So this router will not send any RIP information via E0 by 0, and that this R1 router will not accept any RIP message on this interface also. Both, no sending, no receiving. Okay. Now we are working with RIP authentication. So RIP support two type of authentication, clear text authentication and MD5 authentication. So MD5 authentication is little bit secure as per clear text. So we will be working with both. Okay. So now here we are on R1. Okay. So we will implement this type of security between R1 and R2. Okay. Okay, so we are on R1. See, first you have to understand what is authentication. Authentication means, see, by default what is happening here, whenever you are enabling RIP on R1 and RIP on R2, automatically both routers are exchanging the information, right? Okay, automatically they are exchanging the informations. Okay, but now what is going to happen? Maybe R1 is your, maybe it's a branch router, and R2 is far away and it is also connected as a branch router. In the middle you will have multiple other vendor routers, right? And all are running RIP. But when you have a neighborship, when you will advertise your network information through RIP, automatically other routers will receive those information, right? So if you want to make security between your point-to-point neighborship, you can enable password kind of authentication. So if your password will match, you will receive my information. If password will not match, you will not receive my information. Okay, so let's enable the password between R1 and R2 clear text. You can come here config, you type here key chain name of the keychain, you can say any name, like even you can say my name, key id 1. Okay, key string 123 at password, any password. Okay, exit. Now implement it. So implement on the interface. So come here, interface serial 2 by 0 IP rip authentication mode text. Okay, and then you say IP rip authentication key chain, the name of the keychain. Yeah, this one. Exit. And now what will happen? Then you run here this command, debug IP rip. Okay, you will see something, or better you can run here debug IP. So see, ignore version 2 packet from 12.111 invalid authentication. Means here neighbors it is down now. So between this R1 and R2 neighbors it is down because authentication is not matching. Okay, and if you want to see proper information, okay, so you can delete this link. Okay, if you delete this link, so no update will be received. See, this update is going via like this. Okay, but you can understand here, see, invalid authentication. See, invalid authentication here also. R1 is receiving some kind of invalid authentication from R2. So for that one, what you can do, first you type here on all. Now come here to R2, type here on all, and then here also you can configure same authentication. Okay, first type here key chain j key id 1 string. Okay, now you type here interface serial 2 by 0 IP rip authentication mode text. IP rip authentication key chain. Okay, exit. Now you will see that neighborship is up. Now they will not have any kind of ignore message kind of. Okay, so you can see here there is no any kind of ignore message. See, authentication, and but you can see here, see what is the problem between this authentication. See, you can see this authentication message, see 123 at JKT. So password is visible. That's why most of the companies they do not use this clear text authentication, so they use MD5 authentication. So what we can do here, we can enable MD5 authentication between R1 and R3. So you can see here. Okay, okay, so what you can do here, you can come here key chain, same thing. We have already keychain as a this one key string is also there, but what we can do here, we can simply come to the interface E0 slash 1. Okay, and simply we can write here IP rip authentication mode MD5. okay, and keychain is, that's it. Now you can come here for the same thing, R3 conf, but first you see this message, ignore message. So debug IP rate. Let me first show you the ignore messages, then we will be working on that. See, invalid authentication between R1 and R3. Okay, so on all. Now let's configure it in uh, key chain. Key I did this. Key string. Okay, fine. Exit, exit, and then interface is 0/1 IP rip authentication mode MD5 IP rip authentication key chain. And now if you are checking any kind of debug messages, you will see now everything is okay. So now any packet, when the packets are moving, now it is securely moving from one place to another place. Means R1 to R3 is C MD5 authentication, no password is visible. But if you'll check here on R1, R1 password is visible. Okay, see. So why? Because here we have used clear text. Okay, and here we have used MD5. So here means if any man in the middle will come to sniff the information, so on this link that hacker cannot get the information, but on this link maybe hacker can get the information and can use the same password to become your neighbor and he will get all the information. Okay, so we are done with RIP. Okay, so our next class is EIGRP.